I'm Greg, and I work with NMIS in the Manufacturing Skills Academy, and I'll be giving you a quick introduction before I hand you over to the other fine gents on your screen who will be doing the majority of the speaking today. So before we get started, I've got some housekeeping to cover. The webinar is being recorded and will be made available on our YouTube channel once we're finished today. Your microphones and your webcams are going to be turned off during the session to avoid the background noise. So if you've got any questions, just type them into the chat tool, and there'll be time allocated at the end of the session today where we can put those questions to your speakers. If you want to submit your questions via Twitter, the marketing team will pick them up for us as well, and you've got the hashtag and our Twitter handle on the screen there just now as well. So as I mentioned, today's session is the second in the Manufacturing the Greener Future series. Our first webinar, an introduction to sustainability, is online in the NMIS YouTube channel, and for anyone that wasn't able to attend in December. The final session on life cycle analysis is on the 8th of Feb, and I hope you'll be able to join us for that one. And if you've not already registered, you'll find a link on our webpage to sign up as well. These events are part of the Advancing Manufacturing Challenge Fund and the Low Carbon Challenge Fund, and are funded by the European Regional Development Fund. So today's session will look at Industry 5.0 and its role in sustainable manufacturing future. We'll introduce the concept of Industry 5 and how this builds upon the more familiar Industry 4.0. And we'll also look at some of the opportunities and challenges for manufacturers who are adopting this concept and how it could change the way that we work. So your presenters today are Professor David Butler and Professor Jorn Mehnen, both from DMEM at the University of Strathclyde. David also works on the Extend project, which is part of the Low Carbon Challenge Fund, and I'm sure he'll mention that during his presentation. So, as I'm sure you know, the Skills Academy is part of NMIS, and we're here to help with current and future workers to develop and enhance their skills that they and their employers will need to compete globally in manufacturing. We're building an online training portfolio focused on digital manufacturing, and we also offer a range of other more bespoke services, including one-to-one support and consultation. We can do workshops in a range of different topics, including continuous improvement, remanufacturing, design and innovation, and ED&I. And we can also help signpost you to other organisations where you can find further support. So for those of you that'd like to learn more after today's session, you'll find additional training content on our learning platform, which you can access, which is using the link on the screen just now. I'll also drop that link into the chat at the end of my slides. If anyone would like to discuss in more detail how we can help, just drop me an email and I'll be delighted to have a chat with you. Again, I'll also post my email into the chat at the end of my slides. And a final point before I hand you over to our main speakers, we're currently planning another event. This one's an in-person workshop style event focusing on remanufacturing, another crucial tool towards our sustainability goals. This will be a full day event with speakers and breakout sessions, and we're just confirming the dates and the venues over the next couple of days. So keep your eyes peeled on our website for details of the next event, or indeed drop me an email if you would be interested in attending, and I'll be happy to send the details on as soon as it's confirmed. And without further ado, I'll hand you over to David to start digging into Industry 5.0. Enjoy the session.
Thanks, Greg. I'll start sharing and make a few adjustments on the screen so I can see everybody. Right, so as Greg's mentioned, both of us are academics, but I work my main focus is with industry through the Extend programme, which is funded by the European Union through the Scottish Government, where we go to companies and help them understand where they are on the net zero journey and help them plan, either through energy audits or through road mapping on how they can move forward towards their targets. And to be honest, as we'll talk about it shortly, net zero, sustainability, circular economy, all these terms are thrown around. In the previous webinar we focused mainly on the circular economy. And here I'm going to be touching mainly on sustainability, but leading naturally into Jorn, who's going to be talking about digitalization. So I'm going to play devil's advocate at the end of my presentation and talk about some of the negativities of digitalization in terms of the cost and things we don't realize about how much energy data takes to store. And I think Jorn's going to then argue back and explain, the real pros and cons of not Industry 4, but Industry 5, which it sounds like we're just adding numbers like, we have our telecommunications is 5G, next will be 6G, but there's a lot more to it. And the two probably are, as I put there as a question mark, is a natural partnership in my title. most likely you'll see that there is a natural partnership between them. So without further ado, we have all these terms, but sustainability, it really comes down to the fact that we don't have a second planet. And we really got to think of the wider picture. So we have net zero, which is nice targets, but on a wider picture and a wider view, it's how do we do things more sustainable? And that includes the economics, the environment, and of course the society. A lot of focus has been talked about reducing carbon footprint, reducing environmental impact. But what we don't talk about a lot is the societal effects, about how many jobs will be created through sustainability. So there's lots of options there and opportunities to create new jobs. So we always seem to focus on the environmental side and forget that there's a lot of opportunities, particularly here in Scotland. And we're really seeing some of these coming through in the end of life extension of components, and also new business models coming through for certain industries on how they can make benefit from sustainability. The whole topic really started back in the 1980s to get attention when there was a United Nations report done out by called Our Common Future, and this led into a lot more activities, particularly around the COP series of conferences. And all this was covered in the previous webinar by my MS colleague Jennifer, who went into great detail to explain the various events which have taken place to try to move the world towards a more sustainable future. But from a business perspective, it really refers to how a business can do what it's doing without negatively impacting the environment, the community, and even society as a whole. How do we, first of all, minimize it and ultimately eliminate it? So really, there's two main focuses there. It's on the effect the business has on the environment, which is easily measured nowadays through life cycle assessment, which will be the next webinar, where we talk about carbon accounting. What is your carbon footprint? What is the process? How can you reduce it? And also something which is harder to properly quantify is the effect the business has on society. So the push to make sustainable businesses is going forward with speed. It's also something which is going to be driven. We'll find governments, when it comes to tenders, particularly UK and more recently Scottish government, will be focusing on your plans as a business to show that you've got a sustainability roadmap, and that will be one of the criteria for tenders being awarded going forward. What's driving all this? Mountain waste. We got a lot of waste. Landfill is still one of the most desirable options. It's the cheapest, but of course it doesn't look good. End of life disposal. This has come really to the forefront when we talk about COVID, we talk about Brexit, and the need to see what we got in this country, what resources, how do we extend our life, or how do we mine, something called urban mining, how do we get the value back from our resources. This also links into the fact that if you do it locally, you reduce your carbon footprint on transportation. Silly example is we send metal from the UK across to Asia to be processed, and when we buy the metal back. Just think about all the energy involved in the processing, but also the energy in transportation. How can we do more here? So there's a lot of drivers to do more locally. We also have more on a wider scheme. We have poverty, gender equality, and global environment. And all these are linked into something called the Sustainable Development Goals, which the United Nations and almost all the countries in the world have agreed to follow. And I'll briefly touch upon those without going into far too much detail. Other concepts. So sustainability is one concept thrown around. This is the classic butterfly diagram. It's used I use almost every time I talk about this. This version is from the Ellen MacArthur Foundation, which is a great resource for material as well. A lot of it's free of charge. What I like about it, if you look on the right-hand side, is the options available. So as you go from the top, finite materials are being mined. You're making the parts, making the product, either selling the product or providing the service. And at the end, what can you do? You can reuse it. So the sharing economy is something which gained a lot of attention pre-COVID. Not so much talked about in the last couple of years, but it was big at one stage, and it will probably come back. We also have the opportunities, as you can see, to maintain and prolong the life of parts. Can we sweat the asset? And this is now something which the wind turbine operators are considering. The wind turbines all around Scotland typically have a 20-year shelf life. There's no reason why you can't extend it. So there's a big emphasis now on how do you guarantee the part and also but ensure it can last a bit longer. And why do we put 20 years on it? Is that a manufacturing decision, or is that more of a finance decision? So there's interest to prolong things. There's also the idea of reusing and redistributing. And we can also look at the opportunity of refurbishing a part, bring it back to new, which is remanufacturing with the same guarantee. And that's particularly strong in the automotive industry and oil and gas, and it's getting attraction in other industries as well. The one thing we want to try and avoid, if possible, which is where it gets very confusing, is recycling. Marks and Spencers and other fashion houses sell recycled material, and it's like plastic off the beach, which has been recycled, and now you pay a premium for it. Ideally, that's not the best option because that's required a lot of energy to reprocess it. It's not always the most desirable. So you've got quite a few different terms there. And we do have, and we can't avoid net zero. We had COP26 and we just had COP27. This is something which politicians love the idea of having some kind of measure, and carbon dioxide, the CO2 equivalent footprint, has become the catch-all phrase. What's your carbon footprint? How do you reduce it? You can go online to work out how much your transportation costs in terms of a carbon footprint. It's a great political message, but we needed some metric to use. And the idea is, how do you bring that down to zero? And there's shortcuts which are not desirable, such as planting trees. That will give you a possible short-term success, but long-term, you've got to think about how do you reduce your emissions. So in the next webinar, we're going to be talking about the various scopes. So scope 1, 2, 3. Scope 1 is the emissions inside your organization. Scope 2, where does your energy come from? And scope 3 is the hardest one, is more about the supply chain. And this is happening, particularly in automotive. The big companies are pushing down for their supply chain to ensure that the supply chain is compliant on scope 3 emissions. So it puts a lot of pressure on the supply chains, but it's got to be done sooner or later, and it seems to be being carried out now. I throw this up because a lot of companies have started using these, particularly the multinationals have started picking some of these 17 goals and using them as part of their ambitions and plans for net zero, but also for sustainability. So you've got a whole range here from no poverty, zero hunger, all the way to reduced inequalities, sustainable cities. And number 12, which I think is one of the more important ones and links very nicely into most companies, is responsible consumption and production. How do you position yourself to make sure your product is used the most and can last the longest? So it's quite a shopping list, quite a menu. An example here is SSC Renewables, who I work closely with. They've chosen 4 in particular, which they see as matching their ambition. And this was announced just before COP26. They want to reduce their scope 1 emissions, so carbon intensity, by 80%. That's climate action. Because it's wind turbines, renewable energy, they want to increase their output, generate more with offshore and onshore wind farms. So that gives you the affordable and clean energy. Reduce the carbon footprint to enable low carbon generation, more environmentally friendly. That's industry infrastructure and innovation infrastructure. And finally, how do you ensure that your employees are treated well? Then you've got number 8, which is decent work and economic growth. These do not contradict each other. They can all complement and work together. So most companies will choose a few of these and then commit to them. The ones, and this is an interesting survey carried out, is saying, well, we used to use an expression where I used to live, which is NATO, no action, talk only. So how many companies actually talk about it? How many companies do it? And you can see here, the easiest ones which companies have gone for is decent work and economic growth, which is on the right-hand side in the dark blue. And there's a few more down the bottom, quality education. If you got the list in the middle, you can see how many have not really been at the forefront because they're either harder to prove or harder to achieve. So the easiest ones are decent work and responsible consumption, where you can measure it. So this is the challenge we have. It's a nice list of 17 goals, but how many of them can actually be quickly achieved? Examples of how businesses can do something to get towards these targets. One is using sustainable materials in the manufacturing process. We've seen this in construction with the sources of wood, and even the way that there's new products on the market, new materials available, which are demonstrating the lower carbon footprint and showing their sustainability. The supply chain. So a lot of work is being done with NMIS to work out, why are you buying these particular components overseas? Do you realize in Edinburgh there is a potential manufacturer, so you could reduce your carbon footprint by having a supplier located in the same country at least, or even in the same area? So that's an easy way to do it, and that's a lot of work being done to try to demonstrate how adjusting your supply chains can reduce your carbon footprint. Renewable energy sources. Scotland's got abundant wind, and we're definitely one of the leaders in this area, but it's still also the ability. We've been talking to companies when we do energy audits, and the companies are saying, can we have solar panels? And with the energy prices as they are, the tipping point to actually justify solar panels is a lot better now than it was 9 months ago. So that's one of the options which is coming through. And other examples are more on the corporate social responsibility, which ticks some of the boxes, which is supporting education activities, for example, in the local community. These just a small selection. The responsible consumption and production is one which has got a lot of attention from industry, is the fact that if you really want to go towards a sustainable business practices, selling products may not be the way to go in many, well, obviously some products we have to sell, but a lot of areas, why are we selling a product? The joke is one of our biggest investments in our life is buying a car, and we probably use it for less than 7% of the day. But it is one of the things we buy. It naturally lends itself to servitization, particularly in cities, not in rural areas. And this is why you have companies like Zipcar, and of course we also have the bicycle sharing as well. So this is where the servitization model makes more sense. 5 years ago, Volkswagen made the announcement they want to be the world's largest provider of vehicles, not the world's largest manufacturer, the world's largest provider. So the choice of words was really them saying, we see the future not selling our product, but providing it as a service. It hasn't happened yet, but I mean, it's not going to happen overnight. So that's Volkswagen's ambition. We have different ways of actually servitizing a product. You can sell it to the customer and then buy it back at the end. You can sell it and have a maintenance contract, or you can lease it or share. And there's a lot of examples out there beyond bikes and cars. On the big side, the example always quoted is Rolls-Royce, which provides the engines at power by the hour. No airline wants to own the asset because it sits on their books. So the engines are power by the hour, which works brilliantly when demand's high. During COVID, Rolls-Royce took a hit because their engines were on the ground. There was no income. And that's a big expensive thing. Well, there's a company called Interface in the US and a similar one in the UK, which provides carpets. Companies don't want to buy carpets. It's an asset. So this organization leases the carpet to you. They've designed the carpet so they can remanufacture them. They can strip off the back easier than what currently happens. Most carpets end up in the landfill. They actually designed it in such a way that they got not just the product, but the whole model around it to rejuvenate it, strip it out, reduce the carbon footprint and get it out there again. So companies pay per square foot for material. Another example, which we've all come across at some stage and probably didn't realize, is photocopiers. Nobody buys a photocopier. The photocopiers are leased, and the companies then have the ability to take them back, change certain modules, minimize the actual modifications, but provide even a better or a newer version of the product. So all photocopier companies have been doing remanufacturing and providing their products as a servitization model really since the 1990s. So that's just some examples of servitization. But to get to that, and this is where Jorn's part will also come in, is we need to have a better understanding of the products, if it is a physical product, and how it's used, how it's made. Can we have some kind of passport to give us information about not just the history of it before, when we actually get the product, but during its service? And that can help us either extend the life of it or improve it and make it last longer. We need knowledge. And we can get lots of information, for example, where the material comes from, how it's extracted, because all this shows us something called the embedded carbon footprint, how much energy has gone into this at the beginning. We can even have information for the sustainability development goals, like how much the work has been paid. This week, the BBC has done a survey which says most textiles made in Bangladesh have been made below cost. And I think Marks and Spencer's is now having to explain itself, along with other companies, to why it had these kind of business agreements in place. Transportation. A lot of the wind turbines we see around, the towers are made in India, they're hollow, they're shipped from India to the UK. What you're really shipping is air. The transportation costs embedded into that product can be quite high. And of course, how is it used? And at the end, what is the material of usage? So one of the things we are doing in Scotland, and I mention this every time, is we are currently down at Prestwick, is 2 Boeing 787s being decommissioned. And the challenge is it's a very modern plane. How do you get the maximum value out of all those parts coming off? Each plane is worth 225 million US dollars. How do you reuse those materials to get the maximum value back into, for the company and into society? And if you can't just reuse it, what's your end of life options? Hopefully not burning it to create just energy, which sounds great when you say it's recycled, but it's not the most desirable option. So do you have good end of life options? All this can be captured. And material passports are becoming something which are gaining attention. In fact, there's new legislation coming out or just come out for the EU for batteries, which I'll touch upon in the next slide. But really, to capture information and store it, digitalization is one of the best ways to do it. And blockchain, for example, is one good way. Not talking about Bitcoin here. Blockchain is one good way to actually store information about a part. I mean, you can actually track it through, and by having information, you have more confidence in the part as well. And that could increase the value of the product or the part after you've finished a certain cycle. This has come out from the EU, so by 2026, all batteries will be expected to have certificates, because we anticipate with automotive applications, we're going to have a big problem with end-of-life batteries. Do you understand how it's being used? Because that would also imply if it's got a second life, or it should be broken down and recycled into its constituent materials. So the example here is you got across the center is the green part on this chart, which is all the certificates from where the materials come from, how they're refined, has it been audited to show that it's everything is valid, and then all the way to the right hand side when you get to the production of it, how was it made, how were the cells made, how was it used, which is very important, the cycles it's been through, and has it been repaired. So if all this information is captured on a battery, particularly high value batteries, it gives you a lot more confidence in what to do with it after a certain amount of time. So it helps decision making. And I had this chat with a company in Northamptonshire who was saying that's the problem they have. They don't understand enough about what's coming in, and therefore the decisions they make are sometimes just shred the batteries, cut it all up, rather than actually find a secondary use for it. So it's a bit of a challenge coming our way, and the EU has got this legislation coming through. I gave this example one of the previous times I gave a presentation because I think it's quite good. It looks very mundane, a bicycle. But what information could we capture on a bicycle? If the bicycle, say, becomes a service, then we've got the history of it, how it's made, where's the materials, which we just discussed. So we got the history of the manufacturing. You also got the carbon footprint, the mining, the manufacturing. We can put sensors on to see how the bike's been used, operational data, past performance, and that could be used to help design the next version. We could take the information, work out the weaknesses, it could be the maintenance, could we simplify parts to make it easier to maintain, for example. Bicycles were dying out until suddenly COVID comes and every bicycle shop in the UK was booked up solid because everybody found the bicycles in the garage, and it's become the pastime again. We could do an operational workout, planned maintenance as well. So beyond just the sustainability in respect to the carbon footprint, we could also provide a service about maintenance. We could contact the owner and say, hey, just like the dentist contact you, this bicycle's ready for, come in for its annual maintenance, or we found there's too much friction on a certain part, I think you need to replace it. So you can imagine the amount of value you've got. And if you can do for a bicycle, you could do for beds, hotel beds, why do hotels buy beds? It could be a service. You can capture a lot of data about the usage. Is it kids jumping up and down in it? And does that cause more wear? How do people lie on the bed? You can actually work out how to design a new bed, which actually becomes more modular and extends the lives. And there's a wonderful company in Glasgow called Elite Beds, which is quite ahead in the field in this area. Apart from that, we're capturing all this data, and data is great. we get data and we store it, and I was told many years ago it's a bit like digital diarrhea. You get too much data, it just flows through your fingers. What we forget is there's a cost to data, not to actually the processing and also the storage. And all energy forecasts are shown, the dark blue is the networks, the IT equipment, the ICT equipment is production costs, but look at the data centers in the green. I mean, that's what's taking up a lot of energy, and this is why there's attraction to stick data centers underwater, which they did in Scotland, or build them in places like Iceland, where your cooling costs would be greatly reduced compared to being in the tropics. But this is a real challenge as we capture more data. We've got to think it's actually contradictory in some respects to sustainability, because unless we do something about this, we're going to have a lot more energy consumption. And even storing data is not cheap. It's a luxury, because normally when you store data, it's backed up, usually on hard drives, but there's still the biggest way to back up data is on tape storage. We haven't moved forward since the 1960s. And all this costs money and time, and people have worked out if it's sensitive data, it can cost about $3,000 a year just to store it, 1 terabyte of data. So I'm sure it's coming down in price, but it's a luxury. You've got to protect it. You've got to show you've got GDPR and you've taken all the right precautions. So it's this trade-off, which Jorn will probably now tell you the value of it all. And really, that's where I'm finishing. Just an overview of sustainability and also how important capturing data is. I'll let Jorn take over now, and he will continue on his part on digitalization. Jorn, you ready?
Right, thank you. Yes, I'm ready. Thank you very much, David. It was a great presentation. I'm trying to share my slides now, where I talk about Industry 4, Industry 5, and yeah, a lot. So that would be my screen. And why doesn't that do that?
Yes, you're sharing.
Okay. Can you see the whole screen or just the presentation thing?
It's just the presentation thing, Jorn. I see the arrows across the bottom saying your 12 slides.
I had that before, meant window. All right, so and F5. Can you see the whole thing?
Yes.
All right, good. All right, thank you. Also David and yeah, the whole team actually really for also having me. Also I'm Professor Jorn Mehnen, and I'm giving a presentation. As my presentation is on Industry 5 and its role in sustainable manufacturing, in particular on the area of Industry 5. So that's the particular topic I'll be focusing on. And a little bit of the history. I know, also most of you will know the Industry 1, 2, 3. I will just briefly go really through that. But I thought it's quite interesting to see what happened and why we are in this development of Industry 1, 2, 3, 4, and now 5. Also why do we call it 5? And I saw in the questions already, what's the difference between 3 and 4 and 4 and 5? And I'll cover exactly that now. Plus, also introduce with Industry 5 what the particular concepts of Industry 5 is and how this could be implemented. The implementation part is more my ideas. But as of first, Industry 1, that is from 1760 roughly to 1820. And that is, and you will see that across all the different industrial revolutions, if we call them in revolutions, that this is about more convenience and more power. As a power, the first power, as a first people used horses, obviously, or human power. And that was not sustainable as such for growing. And so with the steam engine, humans were able to cast iron. I don't know, just cast iron. We did that before, but building larger structures, which you couldn't do with a just labor force only. So we had steel bridges, buildings, cities were growing. And with that comes also, yeah, convenience, faster transportation. The world grew together. And that is also something, sort of a common theme through all these revolutions, where you can see that, yeah, power, transportation, convenience, communication, not at that stage in the first revolution, but you will see that also continuously going through all these different revolutions. Then also societal changes. As you remember, as a textile machinery being introduced was very, very powerful for the UK, for example. We had the looms, but there was also a lot of changes in society, of course, and that's why it's probably also really called First Industrial Revolution. But as with that, and different as growing cities, people became also quite wealthy and rich and influential, and particularly as the First Industrial Revolution being invented in the UK. So the UK benefited from that significantly, I would say. And that was also, you would see that other revolutions got rolled out throughout the world. And with that, come to the Second Industrial Revolution, 1871 to, also that's just sort of ballpark figures, 1871 to 1914. Main elements that are characterizing the Second Industrial Revolution is the electrification. Imagine that is when the instead of gas lamps in the cities, we had now suddenly electric light was safer and was also instantaneous. Instantaneous means also more convenient and anywhere, and that's a real big advantage. Also that we had suddenly light. Light was there in 1879, and not too long ago, imagine that, this is the first transatlantic phone call. That is roughly 100 years ago. Imagine today, you get your mobile phone and you call anybody in the world almost. That was 100 years ago, something fundamentally, a change in how people also think of communications. And that has an impact, of course, also on trade and in general, the human society. Mass production, as the Second Industrial Revolution is very famous for the introduction of mass production. Henry Ford in 1913 introduced the assembly line. Actually, was a little bit before the assembly line was already known in slaughterhouses in America. But for the mass production of automobiles, Henry Ford really made that very popular. And the advantage of that was that the handmade, more or less, cars at that time become affordable. That is a big advantage. And again, it is about transportation. Also the Model T, for example, sold in 1925 for, at that time, $260. And with Ford introducing the $5 work day, it was actually also affordable for their workers. That is basically, so you have to multiply that roughly, I would say, maybe by 100 or so. So imagine to keep people in his company, Ford introduced these $5 work days, and that is also has an impact on obviously the society. And they obviously wanted also to sell their cars, so make it more affordable. So every time these industrial revolutions had a significant impact on the society. With more and more cars, though, this has, of course, also an impact on the environment. And we get more streets, more pollution and all that, which was probably not the fundamental idea in the beginning when these technologies were introduced. The third industrial revolution is what probably most of us will be familiar with. This is roughly also the time of my life, the digital revolution. Imagine the first IBM computer was introduced in 1981. And that means that's the first personal computer, so a computer that was affordable by almost a lot of people, at least, and also in offices. So that meant that suddenly also the work environment changed, and then with that was also the change of thinking and how people worked in their environment. Also the typical typewriting was completely replaced, very soon replaced by using computers. And for that, there's also the communication, again, the theme that's going through is that the modern internet as we know it, that is the one that is at 1989 introduced into, in the beginning. Of course, before that was military, but in 1989, it was the introduction into academia and research. And from then, that went into the basically companies with the students that learned how to operate these internets. And the convenience, again, was one of the things that was really, really important. And not just convenience, it was communication. Industry suddenly could really communicate with each other without paper. I remember when I started in industry, that was all about paperless offices. Well, it didn't really happen this way. We have a lot of paper now still, but it's really again these were the ideas. KUKA robot introduced their famous famulus in 1973, and the power as a television, PAL television, 1970s. Why I'm saying these things is mobile phone, the first mobile phone in 1981, and space exploration in 1969. A characteristic throughout Industry 3 revolution is that you basically it's construct, control, and repeat. It is very defined and controlled. Also, for example, television is at that time was something that was delivered to you and you hadn't much choice. And the same was for the robots. The robots were sort of pick place. They did only that what you told them. The programs at that time were all also like that. As you instruct the computer or the robot or the society actually through the television what is available and what they should do, and then you can in a controlled way repeat that. So this is a typical pattern, a thought pattern that is typical for Industry 3. Of course, you can say, okay, we have still digitalization, it's the digital revolution at that time. But that is still swapping into also the fourth revolution. Okay, fourth industrial revolution, that is 2010 to today. Why is 2010? Because in 2010, the Germans in 2011 introduced the so-called RAMI model, Industry 4 model, which became very popular and very famous across the world. And in various variations also it was adopted. But what you get with the fourth industrial revolution is the so-called cyber-physical, as you have a cyber-physical revolution. That is a lot of tools, and they are very famous and very not just popular, very powerful tools, like Industrial Internet of Things. We didn't have that before 2010, not in that way at least. Additive manufacturing, AR, VR, mixed reality. A lot of people talk about that, in particular now. Artificial intelligence, because the computers with the GPUs, for example, and also the way of thinking, we come to that in a minute. Artificial intelligence really took off. Over the last 2 years is probably the power station at the moment that is really driving a lot in Industry 4. If you're not following that, basically, that's probably something that you should definitely follow. Also artificial intelligence and what's going on in this area. Digital twinning, part of cyber-physical revolution. Industrial revolution, also Industry 4 is more the breaking the boundaries between the physical world and the cyber world. This becomes much more flexible, basically. As you can see that easily in AR, VR, and mixed reality. That you have these boundaries between physical and digital breaking out of. But in additive manufacturing, I have something similar. So you just say, okay, this is what I want in the physical, in the cyber world, and almost like that, it comes out in the physical world. So you have a lot more this breakdown of these boundaries. but it's also cobots and sensory technology, autonomous systems, autonomous cars, with all the consequences, of course, are part of this toolbox of Industry 4. What is also typical for Industry 4, and that's a plus and also minus maybe. Also, certainly it was a minus, that's why we introduced Industry 5, is that it is still very technology oriented as such. We have all these wonderful tools here, but there's something missing. And another idea, which is the difference between Industry 3 and Industry 4, is Industry 3 we said is control and repeat, and everything is sort of prescribed. Here we have a different idea in Industry 4. It is more describe the goal, and then like an AI, for example, it finds a solution for you, whatever comes, and it will find you a solution, but you have to describe the goal that you want to have at the end. Like additive manufacturing, this is what you want, and the system will make it for you. It's a bit like almost Harry Potter's wand, if you wish. But you need to know how to operate this wand. And that is why we have Industry 5. Okay, so, oops. That is the bubble diagram that describes the enabling technologies. It's just the overview of those tools that are available. The shortcomings of Industry 4, I'm a promoter of Industry 4, obviously, but there, as you have to be critical with yourself, of course, also there were shortcomings, and that is what Japan realized in 2016. So that is 6 years after Industry 4 was introduced, 5, 6 years, and they said we need to have that more human-centric. They introduced that, they didn't look at the industrial revolution. They said it's a societal revolution. Also for them, Industry 4 was something that has a fundamental impact on society. I don't go through all these different societal revolution now, but they wanted to have something like at the end a super smart society. But what you can still see is that society 5.0, as they introduced it, is still predominantly very technological driven. So basically, they still use this Industry 4 toolbox, but with a Industry 4 thinking, which is very different to Industry 3 thinking. Just as I said, control. So, but that they wanted to introduce that more for the society, but that's the using the tool for the society. And the EU in 2021, now we are almost 10 years into Industry 4, which has not everywhere even been introduced as such or realized as such, but it's because it's a quite complex, it's not just a toolbox or the understanding and the knowledge that people need to operate these tools. That is also, as I said, is a different way of thinking altogether. And Industry 5, as it was introduced in a paper from the European Commission in 2021, has these main 3 elements. That is the first on the top of this triangle. I hope everybody can see that. Is the human-centric. We have that a little bit also with the Society 5.0, but here they particularly focus not on how to put the technology to change the society. It's more that this is the real way of changing the way of how industry works with their environment and the humans also, everybody else in the environment work. So the whole idea of Industry 5 is more that the approach, the thinking approach, if you use these tools, Industry 4 tools, they should be more human-centric. That is for promoting talents, diversity, and empowerment of the individuals. That is also explained here a little bit more in detail on the left-hand side here, where I say, this is directly from the European Commission. Industry 5 is characterized by shifting the focus from the shareholder value to the stakeholder value and reinforces the role and the contribution of industry to society. And that is particularly reflected here in the top, where we talk about human-centric. The shareholder value is basically the people that financial oriented, and stakeholder, this is all of us, that is including the industry, of course. So the other element is resilient and sustainability. David talked quite in detail, of course, on sustainability. So what we want with Industry 5 is that we have the Industry 4 technologies that we have to help with increasing sustainability. That's why they call it Industry 5 revolution. It is a completely different way, and getting that different way of sustainability first instead of just shareholder value is a quite revolutionary or very, very challenging approach in the first place. What is also, it replaces the well-being of the worker and at the center of the production, and uses new technologies to provide prosperity beyond jobs and growth. But what they also acknowledge is that it is basically an addition or complements the existing 4 approach, which is that by using sustainability, resilient, and human-centric ideas. So we have the Industry 4 technologies, and on top of that, like an augmentation, comes the Industry 5 element. Okay. What is really important, of course, with that is also that Industry 5 requires an architecture, a trust architecture. I don't go through the details here. This is not the time for that. But what I'm describing here is the different levels of trust. On the top, you can see the different trust features, which were recognized by the UK funding bodies, EPSRC. That is responsibility, resilience, security, functionality, verifiability, and governance. So for that, we have actual large research centers in the UK that just focus on these elements within Industry 4. The pyramid that you can see here is in what level, or if you design something, I use this very much for my design students, at what level are you, for example? Is it just smart connectivity, or on the very top level is self-autonomy or even distributed autonomy? And with these different levels, you get also different complexities of trust. And that is what you have here on the right-hand side. This is sort of an overview. If you want to assess yourself, basically, or if you have a design, or if you have for your own company, you can actually see where you sit on that pyramid and how the corresponding trust complexities look like. All right. And this is the last slide. This is how I think this could work for Industry 5, so that we have something like an organism approach. As you see your factory almost like an organism, is something that you live with, but the factories also live with you and the environment. The most important word that or phrase that is there is the perfect symbiosis. So what you want is that in Industry 5 is emerging as an age of augmentation, where the human and the technology work together in perfect symbiosis with each other. So if you design something or introduce a new technology, then you would see that almost like an organism, as something that you would look and care for. And it's also other way around. It's the people that buy things. As a bicycle you would not usually care for, but if you could say, this is my bicycle, I live with that bicycle or with that car sometimes even, then that's a completely different way of producing and designing things. Then what is also a big difference in Industry 5 to Industry 4 even, is the acceptance of uncertainties, which is in Industry 4, you would not have that by default. Particularly in AIs, you can totally see that. They don't ask back usually. They don't. They just tell them that's what I want, and they build that for you. AI in augmented reality, we would say, okay, this is what I want to see. This is my environment. There's no direct interaction, and with additive manufacturing is also, this is what I want, and then the system gives you that output without accepting uncertainties. And this is something that with Industry 5 you get more these uncertainties that you have to think about when you design new ideas. And as I said, the most important for me would be this idea of the symbiosis between things, whatever that is. Could be the company, it could be a design, it could be a service or software even, and the human. And with that, we come to the end. EU comes with some AI regulations, and what I also would see is that we have what is really important and that's why we have these classes, this upskilling and introducing of the new ways of thinking. And I'm absolutely happy to also talk to and being invited to give presentations on those topics. And yeah, last but not least, also be creative, bold, ambitious, people-oriented. Also David will recognize these values. These are the Strathclyde values, but as I would also say, collaborative and compassionate, because you need to be compassionate also with your product and your environment. And with that, we come really to the end of this presentation. Thank you very much. Okay.
Thank you so much, Jorn, and thank you also to David for the presentation, for the slides before Jorn came on. I've got a few comments and some questions in the chat. If you just bear with me, I'm going to work my way through those over the next 5 minutes before we finish. Couple of comments initially. Industry 5 has only one main aim: to build a wasteless world for all, and 1 million megatons of waste have already been prevented since 2019 from implementing Industry 5.0 principles. Thanks for those comments into the chat for us. Couple of other comments about the fair work and fair pay. Quite positive feelings of that playing into Industry 5.0 as well. Not really any questions, just a positive that it's been included and being looked at. I think we've got one about the main differences between Industry 4 and Industry 5.0, but I think that was before Jorn's presentation, so I think we'll have taken care of that by now. Let me see. Okay, I think, unless anybody else is seeing anything there that we've not picked up. Also, good comment on Harry Potter being integrated into Industry 5 presentations. Quite a few people very impressed by that. That was the most liked post that we saw in the chat. So good job, Jorn. Always nice to see a Harry Potter mention.
Fair enough. Okay, we'll do it again.
And yeah, I think